besides the fact that you have a test. It means if you failed the quiz from Friday, which, by the way, I will pass back to you today, you have until the end of the day Thursday to make corrections or retake it. Now, I recommend you do it before that day, right? Before test day, so that we can clear up anything that you're still having trouble with. But the hard deadline is Thursday by the end of the day. And if you have any other makeup work, that has to be turned in by then. So here's what we got. We have this graph. Also, hello, I hope you had a nice weekend. Happy Monday. So we have this graph. There's how many parts to this graph? 3. That means it has got how many vertical asymptotes? 2, right? So give me one of them that you can tell just by looking. At -2, and where else? 3. How many roots do you see on this graph? 2. Where are they? -1 and 4. So what we're going to do, the very first thing, is use those asymptote and that root information to get factors. So I'm going to do that thing where I write the explanations down the left side. I highly recommend you also write the explanations down so you can remember later what the process is. Bless you. And the first thing we're going to do is label root and asymptote information. So you're going to get factor forms, and whether squared or not. These are the decisions you're making, whether squared or not, whether to square or not to square. That is the question. And so we already talked about both asymptotes. What's the one on the left that you told me? The left? Right. So I'm going to draw that in so we can see it. And then here's what I want you to label on the graph, okay? That is x equals -2. That's its form as a line, equation of a line. What factor gives you that as an asymptote? X plus 2, right? The opposite. So our job now is to try and figure out if that factor needs to be squared or not. So here's what you need to remember from the T part of your Schrade. When the factor is squared for an asymptote, that means the behavior on either side is coming together. Those parts of the graph are either coming together going up, or they're coming together going down. That would mean your factor is squared. Here's what's happening on this asymptote. Here's the left side of it. Here's the graph on the right side. And here's the behavior. If you were tracing it, are those pieces coming together or going away from each other? They're going away. What does that mean for the factor? Squared or not squared? Not squared. Perfect. Okay. Together means squared. Away means not squared. So they're going away. So it's not squared. Okay, that's the behavior on either side, away. You do that, what I just did, for this other asymptote right here. Take a minute and try that with all that same information, but just for this asymptote. All right, Miss Julie. This is blah, blah, blah. Miss Fadia's talks take 2. This is the asymptote, x equals 3. What factor gives me that asymptote? Julie. Are you Miss Julie? Julie? Miss Julie. I called on Miss Julie. No, I did not. Okay. What's the behavior on either side? Together or away? Ah, perfect. It is away. And so, does that mean it's squared or not squared? Perfect. Thank you. Not squared. Okay, so that is our asymptote information right there. How many roots did we already figure out this graph has? 2. So let's talk about those. So here's one, and here's the second one. So this root right here is the point -1, 0. Now at roots, we're not looking for we're not looking for away or together. What are our 2 options for roots? Bounce or pass through, right? A tangent or a cross. What is happening at this root? Cross. It's crossing through. So that's first of all, okay, so I'm going to write cross right here. I meant to ask you first what the factor is that gives me -1 for a root. And it's just x plus 1, because it's the opposite sign. So it crosses through. Does that mean the factor needs to be squared or not squared? Not squared. Okay. What would the behavior have to be on a root in order to square the factor? It would have to be doing what there? Bouncing. Okay. You try the other roots by yourself. So what I just did, you try it for that one. Aiden. This point is 4, 0. What factor gives me that root? Okay, perfect. And is it crossing or bouncing there? And does that mean it needs to be squared, Aiden, or not squared? Perfect. Raise your hand if you got that right. You got all that. Okay, excellent. Y'all are so smart. So here's what we're going to do with that information now. We are going to write the factored form with an A. But I have to remind you about something, okay? These are rational functions, which mean they're in fraction form. And we just found a bunch of information about roots and asymptotes, right? Which thing goes in the top? Roots. And therefore, asymptotes go on the bottom. So when we go set up our general form, it's going to go like this. Y equals. And your root factors go on top. So what did we say the root factors were? We said x plus 1 and x minus 4. They weren't squared, so they're going to look just like that. And you'll put your A out front here. And then your asymptote factors go on bottom. Those were, let me slide up, x plus 2 and x minus 3. We really would love to know what the A value is. Right? The reason why we can't figure that out right now is there's too many variables floating around. There's an A, there's X's, and there's Y's. In order to solve for A, I need all those X's and Y's to have numbers in them. Bless you. And here's where we just take a point from the graph and plug it in. So I'm going to call it a pretty point. So plug in a pretty point. And I'll explain that in a second. And solve for A. By pretty point, I mean a point on the graph that has integer values, because it'll make your math easier and more precise, okay, more accurate. So sliding back up to the graph, let's use this point right here at 2, 3. Okay, this is my pretty point. Remember, this is an XY ordered pair. How that's helpful for us is, now everywhere in our general form we see an X, what are we going to put in for it? 2. And everywhere we see a Y, we're going to put in the 3. And then that will have numbers everywhere, and all we'll have left to do is solve for the A value. So here's how that goes. So here's my general form. What am I putting in for the Y? 3, thank you. A stays A because we don't know, that's our unknown. And there's X's everywhere. What do they all get? 2. So put 2 in everywhere you see an X. And this is one of those things that's not really hard, but students kind of doubt themselves a little bit because it's a fraction and there's parentheses and negatives everywhere, and then they just wait for me to do it. Here's what you're going to do. You're going to use your order of operations first, okay? So that means P stands for parentheses. Simplify all the parentheses you can find first thing before you do anything with the fraction or anything with the A. So every place there's math inside, you go ahead and do that. And then just let them sort of hang out there for a second. And what comes after P in the order of operations? E for exponents. Were any of our factors squared? No. So we don't have to do E here. But you see how in some problems you would have to remember that step, because sometimes some of your factors will be squared. But in this case, there's no exponents. So we can go straight to multiplication. So I have a multiplication here, 3 times -2. And the bottom 4 times -1. So after I do those, I have -6a over -4. And what can I do to both sides here? Yes, ma'am. Multiply by -4 to both sides. So that gives me -12 equals -6a. And then all I have left to do, divide both sides by -6 so that a equals +2. And that was very satisfying. It's an integer. The negatives went away. I would really like to be done, but I'm not done, because what not? Why not? What is the problem actually asking me for? Not just a, but what? The equation, right? And so we do have it mostly fixed. We need to take the a, plug the a into the factored form that you did a few steps ago. And then this will be your final equation. Y equals a, which is now 2, times x plus 1, x minus 4, all over x plus 2 times x minus 3. I'll slide this up in just a second. Just as a heads up, in the future, if you go off to college and you're going to take more math and you have a problem like this, your professor may not want it to be y equals. They may want it to be in function notation, f of x. They may also ask you to expand out those products of the binomials, right? Actually FOIL those out. I'm not going to ask you to do that because it just, you could have done all this beautiful work and gotten this correct and then messed up your FOIL, and now I have to count the problem wrong. So foiling is not a skill for this unit, so I'm not going to ask you to expand that. It's okay to just stop right here. One interesting thing, though, about the A value. What is your A value? 2. Where in this graph do you see the value of 2 playing an important part? Something that's from our Schrade. Cassie, what is it? What were you just doing? The horizontal asymptote. Look right here. This is not a coincidence. See that horizontal asymptote at y equals 2? Now you can't, I'm not telling you to just look at the graph and figure out what your A is. We are doing it algebraically. It's not always true that the A is going to be the horizontal asymptote, because in this case, if your horizontal asymptote is y equals 2, you already know this graph. Is it balanced or top heavy? I'm sorry, bottom heavy. Is it balanced or bottom heavy if the horizontal asymptote is equal to 2? It is balanced, because bottom heavy graphs or equations have a horizontal asymptote that's always what? 0, y equals 0. So in that case, you wouldn't, if you had a horizontal asymptote of 0, you wouldn't want to just go, oh, hey, A equals 0, and plug it in, because it would simplify to just 0. So you don't want to do that. But let me just show you in this step some more about the horizontal asymptote. Now, I said I'm not going to ask you to FOIL that out, but if you did, think about the first terms that you would get. The f step here on the numerator would give you x squared, and you'd multiply that by the 2. In the bottom, the first terms, or the f of FOIL, would also give you x squared. See? That's balanced. And if you were doing Schrade like you were last week, these would cancel, leaving you 2, and then that would be your horizontal asymptote. So it's not a coincidence that we got 2 here. So that's just an interesting observation, okay? It's a way of double checking your work if it's not bottom heavy. So I wanted just to show that to you. What I'm going to do right now is give you your homework. It is not phone time, because we are doing number 68 together. I'm going to give you a few minutes to try it, and then we'll talk about it, and then, and only then, will I leave you alone. So when you get this, please do this one for a few moments. So real quickly, you have 2 asymptotes. We have this one at x equals -3, which comes from the factor x plus 3. And what are these 2 pieces doing? What's their behavior? Together, right. And so what does that mean? Are you squaring or not squaring? Squaring, very good. Okay, so this is together. What's happening at this one? Going away. So that's the difference in the 2 different behaviors that you could see. So this asymptote is x equals 3. Its factor is x minus 3. It's away, right? So it's not squared. So it's going to be x minus 3. And then there's just one root at 0, 0. You can write that in factored form as x minus 0, or x plus 0, or just x. All 3 of those things are equivalent and will get you the same answer. The next thing, though, is it bouncing or crossing there at the 0? Crossing. Therefore, the factor is squared or not squared? Not squared. So it's just that. And then you have this pretty point at -2, 2. So here we go. So y equals a times x minus 0 over x plus 3 squared times x minus 3. We're putting in -2, 2 for the x and y. The positive 2 is going in for y. Negative 2 is going in for all the x's. In this particular problem, if you forgot the squared, you actually end up with the correct answer. Another reason why we always ask you to show your work, just so we can make sure you were doing it right. So that gives me negative 2a on top. I'm going to combine some of the PEMDAS steps here for just a second. In the denominator, negative 2 and 3 is 1. 1 squared is still 1. And then in the other parentheses, you have negative 5. And then on the bottom, negative 5 times 1 is what? Still negative 5. So I'm just going to scratch that out and pretend like we did that math. And then what do I do to both sides there to start solving? Multiply by negative 5. So that is negative 10 equals negative 2a. Divide both sides by negative 2. A equals 5. And then you just plug that back into that factored form, the general one that you found, and that will give you y equals 5x over x plus 3 squared times x minus 3. Okay? Questions? All right. You have the rest of class